Today I'd like to take you through a couple examples of natural logarithms. You're going to notice some similarities between these and the previous lesson, logarithms, and their properties. In this first example, you're going to notice a similarity in the property that we use in order to combine or condense the logarithms together. Anytime we see two logarithms on the same side of a problem, we want to put these together into a single logarithm. And we can do this by focusing on what is happening in between these logarithms. If they are subtracted, we're going to turn this into a division problem. So I'll rewrite this as the natural log of 4 divided by x plus 8. Now that I have a single logarithm equal to a number, I can use the loop to solve. But here's where you're going to notice a key difference between these natural logarithms and the log logs that we dealt with last week. Previously, if we had a missing base, the base number was 10. But in a natural logarithm, the missing base or implied base is a base of e. We're going to use the loop method to solve this. E raised to the 5th power set equal to 4 over x plus 8. Now, e has a value. It is not a variable. I'm trying to solve for x, and since x is currently in the denominator, that's my first step I want to do. Get this out of the denominator by multiplying both sides by x plus 8. In this step, your first inclination might be to distribute, but I want to remind you, if you're trying to solve for x, the goal is to get things away from the x, so distribution actually defeats that purpose. Instead of doing distribution, let's go ahead and divide both sides by e to the 5th power. My final step is to get x completely by itself, and I'll do this by subtracting 8 on both sides. Now, my instructions tell me that I'm going to round my answer to the nearest 10,000th, or 4 decimal places. I can use my calculator to do this. Let me pull up my calculator and let's talk about some of the ways to set up your calculator in order to do rounding. If you go to the mode in your calculator, you're going to notice this line, float. If your calculator is set to float, that means that it does not do any rounding at all. Since we want the calculator to round to 4 decimal places, I'm going to set it to the number 4 and hit enter. Now that I've done that, I can quit this screen and let's go ahead and work our problem. We need to do 4 divided by e to the 5th. You're going to find the e on the left-hand side of your calculator, e to the x. So we'll use second ln to access this. I'm going to go ahead and put the 5th power there. I'll use the right arrow button, and then I can put subtract 8. When I hit enter, you can see that it has already rounded my answer to the nearest 10,000th, negative 7.9730. Here's another example of this same type of problem. This time when we combine the two logarithms together, they are being added, and therefore I'm going to change this into a multiplication problem. I'll rewrite this as ln, and I'll multiply 3x squared times 3 to get 9x squared. Since I have a single logarithm equal to a number, I'm going to write down that base, which is an e, and I'm going to use the loop to solve. E squared is equal to 9x squared. Now remember, focus on what you're trying to solve for. I need to get the x completely by itself. I'll start the process by dividing both sides by 9. Now I don't want x squared as my answer, I want just an x. So I will take the square root of both sides, and I'll make sure and add a plus or minus sign on the answer side. Again, I can pull out my calculator in order to find out this answer. To use the square root, I will do second x squared. Since this is a fraction, you have the option of doing alpha y equals enter to enter it in fraction form, or you can just enter it as a division problem. Second ln gives me my e to a power, which is 2, and then I'm going to divide that by 9. Double check to make sure that your problem is entirely underneath the radical as it should be, and then hit enter. My final answer is 0.9061. This third example starts off the same as the previous ones. I have two ln's on the same side, and I do need to combine those together. Since it is currently subtraction, I will combine them using division. So x squared minus 7 will go to the top of the fraction and 7 to the bottom. What makes this problem different is that I have a single logarithm equal to a single logarithm. And we talked about this last week, saying that in this case, we can cancel out the logs. X squared minus 7 divided by 7 will be equal to 27. So now let's solve for x squared. I'll start off by multiplying 7 on both sides. So I've got x squared minus 7 equals 189. Now I'll add 7 to both sides. So x squared equals 196. And then finally, I will take the square root of both sides and make sure to add a plus or minus on the answer side. My final answer is x equals plus or minus 14. In these next three examples, you're going to notice that these look similar to some problems we solved before, where we got the same bases and then the exponents were equal to each other. In this case, I cannot rewrite 10 as a number to a power or 91 as a number to a power, and so I'm kind of stuck. But we can use logarithms to solve. In truth, you can use either the log log or the natural logarithm in order to solve this. But we're going to use natural logs since this whole lesson is dealing with natural logarithms. So what do? We're going to take the log of both sides. By doing this, it allows me to use one of the properties I learned before. If I have an exponent, I can bring it to the front as a coefficient. Once I do that, I can easily solve for x by dividing both sides by the log of 10. Again, you'll want to pull out your calculator in order to do this. So I've got ln of 91 divided by ln 10. My final answer is 1.9590. Number 5 is the same type of problem, but before we can take the log of both sides, we must isolate the part of the problem that has an exponent that is a variable. So I've got to start off by subtracting 5 on both sides. Now that I've done this, I can take the log of both sides. Bring my exponent to the front as a coefficient. And solve for m by dividing both sides by the natural log of 14. Pull out the calculator. I'm going to take the natural log of 49.4 and divide that by the natural log of 14. My final answer is 1.4778. I'm not going to work through this entire problem, but I just wanted you to see it. Same type of problem. This time you want to isolate this part of the problem, and you're going to do that by dividing both sides by -7. The goal is whatever you want to solve for, before you can take the log of both sides, you're going to have to get that part all by itself. So make sure you do that when you're working a problem like this. In these last two examples, you might notice that we have an e, but we don't have a natural logarithm. If e shows up in your problem, then we know natural log is going to be a part of our problem also. Just like we did before, let's isolate this part of the problem. This is the part that has the variable as an exponent. So let's start by subtracting 10. Now I have e raised to the n-6 power equal to 48. Just like I did before, I'm going to take the log of both sides. I'm going to bring my exponent to the front as a coefficient, and I'm going to solve. Now there's one more property that you need to know about, ln of e. Just like before, we talked about that if the base and the number were the same, then the exponent was the answer. Remember, the natural log has an implied base of e. So if I wrote the e down here, and I asked you what the exponent was that is right here, you should say 1. E to what power equals e? 1. So anytime you see ln e in your problem, you can replace ln e with the value 1. So 1 times n-6 is just n-6. The final step to solve this problem is going to be to add 6 to both sides. You'll want to pull out your calculator in order to do this. So natural log of 48 plus 6 is equal to 9.8712. All right, let's work through one last example so you can see this one more time. Again, if your variable is an exponent, the best way to solve this is to take the log of both sides. But you must start by isolating that part of the problem. So I will begin by dividing both sides by -10. Once I've done this, then I can take the log of both sides. I will bring my 6n to the front as a coefficient. As I taught you in the previous lesson, if you ever see ln e in your problem, you can replace it with the value 1. 1 times 6n is just 6n. My final step to solve for n is going to be to divide both sides by 6. And I'll use my calculator to help me with this. ln 7.99 divided by 6 is equal to 0.3464.